Hi, welcome all to my new video, that is graphic representation of the data. In the last video we had done the graphic presentation overview, how the data is to be represented. So the data can be represented by various means of modes, through the diagrams and through the graphs. And the following categories need to be discussed for graphical representation or presentation of data: the pie chart, the bar graph, the statistical map, the histogram, statistics in practice, the frequency polygon, time series charts, distortion in graphs. It is important to choose the appropriate graph to make statistical information coherent. So the pie chart, we are going to start with the pie chart, the race and ethnicity of the elderly. Pie chart, a graph showing the difference in frequency or percentage among categories of a nominal or an ordinal variable. The categories are displayed as segments of the circle. The categories are displayed as the segments of circle. That means the pie chart is representing a circle, and under the various segments we are going to display the category whose pieces added up to 100% of the total frequencies. So we are going to divide the whole circle in sort of segments. Then when we are going to join up the different segments of a circle, it will become 100% of the total frequency. Like this. See an example. This is the pictorial representation or representation of pie chart. It is known as the pie chart. That means any data which can be represented in the form of circle through the different segments. As you see that white colored, white or some, it is mentioned as white, but it is not white, it is blue. So it is of 87.7%. Black population. This shows the population, annual estimate of US population 65 years and over by race in 2003. So 87.7% are the white people, the population of white. Black 8.3. American Indian 0.5%, Asian 2.8%, Pacific Islander 0.8%. Two or more is come out approximate 0.6%. Too many categories can be messy. So this is the pictorial representation of population in US depending on their ethnicity and race. So we can reduce some of the categories. We reduce almost in 3 categories, as you will see that white, black, other and 2 or more. Other and 2 or more. For the simplicity, because major quantity is represented in white and black. So white is again without any change 87.7%, and without any change black is also 8.3%, which is already mentioned in the previous pie chart. And all other categories are added up and come out equal to 4%. So this is the pictorial representation. As we see the already done in the last video, the advantages of pictorial representation, that it leaves a lasting impression. So pie chart, bar diagrams leaves a lasting impression, and it is easy to understand and easy to get the analysis about any survey. The bar graph, the living arrangements and labor force participation of the elderly. Bar graph, a graph showing a difference in frequency or percentage among categories of nominal or ordinal variable. The categories are displayed as rectangles of equal width with their height proportional to the frequency or percentage of the category. So again, this is a pictorial representation of a data in the form of diagram, and the diagram is known as bar graph. So bar graph are nothing. There are vertical columns of equal weight. Their height can be vary depending upon their frequency or percentage of the category. Okay, but their width must be equal. So this is the presentation of bar diagrams. We categorize some categories: living alone, that's mean living arrangements of a males 65 and older. The males who are of the age of 65 and older than that in United States in year 2000. So those who are living alone, they are in between 10 to 20. Married males, which is above 70, and others, which is exactly equal to 10. So we can represent the data in the bar form, and you observe that while representing the data, the width of each bar is constant, not varying. Their height can be vary, which is depending upon the numbers or the data. Okay, so we categorize under three categories, that is living alone, married, and others. And the subcategories are having the following data, which can be represented in the form of bars. And it is easy to understand, easy to manipulate, easy to get the survey, easy to get the details about the survey. Okay. Now, if you want to go for the display of information by splitting, that is, in a same bar diagram, if we want to represent for both males and females, that is living arrangement of males and females, which is more than 65 years of age, that is based on the gender, near 2003. So living alone, so by the color, blue color shows the males and maroon color shows the females. So these are the statistical data, and these statistical data can be represented through the diagrams, and this method is particularly known as the bar diagram method. Again, this is the representation method. You can done or you can do in this way also, depending on your choice. For better understanding, percentage of man and woman 55 years and over in the civilian labor force. So we just representing the man and woman in the civilian labor force in the form of percentage, and the criteria for measuring that is one who are having the age more than 55 years or equal to 55 years. So you can easily understand this bar diagram that those who are having the 65 plus age, the women's come out to be 9.8% and the man's come out to be 18%. The age group from 60 to 64 for women is equals to 44.3, for man is equals to 57.2%. And under the category of the age 55 to 59, women's are of 63.4% and men's are of 77.1%. So these calculations are calculated and just represent that data in the form of bars or pictorial representation through pie chart for better assessment or for quick assessment of the data. The statistical map, again, the next method, that is statistical map. The geographical distribution of the elderly, we can display dramatic geographical changes in American society by using a statistical map. Maps are especially useful for describing geographical variations in the variables such as population distribution, voting patterns, crime rates, or labor force participation. The statistical map is the geographical distribution. See this. This is the map. And in this map, each state is mentioned. And in the states, we just mention through the colors. The data are through the colors. Bureau of the Census is 9490 press release. Population estimates. These are the population estimates. And this is the black and white picture. So we are not able to recognize. But you can see that lighter. The one which is very light, they are having under 50%. One is which is more than the more darker than this light, is 50 to 74%, and more darker than 75 to 90%, and 100% in a very dark regions. Current population report. Percentage increase in population 65 years and over. So this is the geographical representation. Percentage black of total state population 65 years and over. As a heading mentioned that what is the percentage of blacks of total state population, and those who are having the age greater than 65 years, more than 65 years of age in year 1991. So again, the white portion is showing that under 5%, blacks are having 5%, and something more darker than white is 5 to 9.9%, and the most darkest shaded portion is 10% or more. Now the histogram. What do you mean by the histogram? What is the definition of histogram? How the representation of data can be done through the histogram? Histogram is a graph showing the difference in frequency or percentage among categories of an interval ratio. This is very important point. That is, if you are going to show the difference in frequency or percentage among the categories of an interval ratio variable, the categories are displayed as continuous bars, width proportional to the width of the category, and height proportional to the frequency of percentage of that category. That is, histogram is basically a method of presentation of data in which it is almost similar to the bar diagram, but in bar diagram we restrict one condition, that the width of the bars is not going to be changed, but in the histogram the width and the height is changed in accordance to the condition. So the age distribution in US population 65 years and over, 65 69, 70 to 74, 75 to 79, 80 to 84, 85 to 89, 90 94, 95 plus. This is the age distribution. And again, this is the another way of representing 85 plus, 80 to 84, 75 to 79, this. Males and female. Combinedly in this way, we are going to categorize for the males and females simultaneously. This is known as the histogram. Views population by gender and age simultaneously on the basis of the age and for both male and female. Now the next one is the frequency polygon. Frequency polygon is a graph showing the difference in frequency of percentage among categories of an interval ratio variables Points representing the frequency of each category are placed above the midpoint of the category and are jointed by a straight line. So the frequency polygon method is method of representing the data under the graph category, not in the diagram category. So on the basis of the data, you are going to draw the graph by joining the points. Either you get a curve or either you get some sort of straight lines and all that. So the frequency polygon, population of Japan age 55 and over 2000, age 55 and over 2000, 2010 and 2020. So see the graph. Here we are representing the population of Japan for the people who are having the age 55 and more than 55 in year 2000, in year 2010 and in year 2020. So in year 2000 is denoted by blue line. In 2010, population represented by violet line, and year 2020, population represented by yellow line. And these are the population data on y-axis. So you can easily estimate the population over the period, and you can draw the prediction also. But if you want to ask the prediction in between, then the exact prediction cannot be done through the graphs. Time series chart. Again, this is the method of representing the data. Time series chart, a graph displaying changes in variables at different points in time. It shows time measured in units such as years or months on the horizontal axis and the frequency, percentage or rates of another variable on the vertical axis. See the graph. Percentage of total US population of age 65 years and above from 1900 to 2050. So starting from 1900 till to 2016, we just divide a scale in a constant quantity in the x-axis and a scale in a constant quantity in y-axis in the form of percentage, 0%, 5%, 10%, 15%, 20%, 25%. Okay. So this is the way we are going to representing through the graphical method in a time series method or in a time series manner. Again, this is the representation for on the gender base, the population for males and females. Distortions in graphs. Graphs not only quickly inform us, they can quickly deceive us, because we are often more interested in general impression than in detailed analysis of the numbers. We are more vulnerable to being saved by distorted graph. What are graphical distortion? How can we recognize them? So this is all about the diagrammatic and graphical representation of the data, and further more discussion is going to be due in the next video. Thank you for today's video. We are not having any problem in identifying the smallest and largest value, but in continuous discrete type or in class distribution type data, you need to get the lowest and smallest value according to the given methods. Just make a note of it. Now see the example based on range. The yield is given in front of you. The yield of a cotton variety from 5 plots are 8, 9, 8, 10, and 11. Find the range. So first you arrange this series in ascending order, and after that, by a simple observation, you are able to find out the largest and the smallest value, and just take the difference of the largest and the smallest value. You are able to get the range. So smallest value is 8 and the largest value is 11. Do the subtraction, largest minus smallest, 11 minus 8, it come out to be 3. So range is equals to 3. Now for example second, this is the frequency distributed type data in a classical class range. Calculate the range from the following distribution. The class range is defined as 60 to 63, 63 to 66, 66 to 69, 69 to 72, and 72 to 75. So the class is arranged in an increasing order already. And these are the some numbers. That is the frequency 5, 18, 42, 27, and 8. Now, for class distribution type data, the method second I had already told you, or we had discussed how to find out the range. So, for smallest value, the smallest class having the smallest value, and for largest class having the largest value is the value. So the upper boundary of the highest class is 75, and lower boundary of the lowest class is 60. So range is given as lowest minus smallest. It is come out to be 15. We are not much concerned about the frequency. Okay. So we are concerned about the range, or we are concerning about the range, then we are talking about the class range. And we are talking about the class range, then we are identifying the smallest and the highest value from the class range itself without involving the frequency. Now, what are the merits and demerits of range? Merits: it is simple to understand, it is easy to calculate. In certain types of problems like quality control, weather forecast, share prices, analysis, etc., range is most widely used. Demerits: these are the 5 demerits. It is very much affected by the extreme items, obviously, because we are considering the extreme values, so it is much affected by the extreme items. It is based on only 2 extreme observations. It cannot be calculated from open-end class intervals. It is not suitable for mathematical treatment. It is a very rarely used measure. It is not widely used, it is rarely used. Now, come to the next topic, that is standard deviation. It is defined as the positive square. Yes. While studying the standard deviation, I'll let you know one thing, that for calculating the standard deviation, you have to memorize the formula for the standard deviation, which is given in the slide or which is given in any standard book. You find the same formula, because to calculating the standard deviation, without formula, the standard deviation cannot be calculated up, and the formula is quite bit little easy to understand and memorize. So standard deviation is defined as the positive square. Its definition is started by the formula itself. So it is defined as the positive square root of the arithmetic mean of the square of deviations of the given observations from their arithmetic mean. So the standard deviation definition is defining the formula only. So it is defined as the positive square root. You just watch the formula. It is the square root of the arithmetic mean of the squares of the deviation of the given observation from their arithmetic mean. The standard deviation is denoted by S in case of simple and raw data, and Greek letter sigma, that is the symbol sigma, is used in case of population. So the formula for calculating standard deviation is as follows. S equals to square root summation x square. That is, x are the values of observation given to you. You have to square all the observation individually and do the summation first. Okay. After that, you do the summation do the summation of all the observation and put over in the formula and do the square and divide by the number of observation, and finally divide the whole by n minus 1. This formula is used for raw data or ungrouped data. So kindly make a note of this formula. This is the main important formula for calculating the standard deviation, and the standard deviation defined on basis of this formula only. And for grouped data, the formulas are, these are the formula for grouped data. One is for the discrete type of data and one is for the continuous class type of data. So you have to just note down the formulas and use these formulas while calculating the standard deviation. So start with one example and you are able to understand the standard deviation thoroughly. Now take the example based on raw data and we are going to calculate the standard deviation. The weights of 5 ear heads of sorghum are 100, 102, 118, 124 and 126 gram. Find the standard deviation. So for finding the standard deviation, the 5 observations are given to you. Number of observation is 5. Now make a table and in that table write all the observation and do the summation of all the observation that come out to be 570, and create the second column and do the square of all the observation. 100 square come out to be 10,000, 102 square, 118 square, 124 square, 126 square and so on, and finally you do the sum of all the x square values that come out to be 65,580. Now observe the formula. According to the formula, you have to put all these values in the square root. First of all, put the summation of x square. So in place of summation of x square, you are going to put 65580. 65580 minus, now summation of x. You put the summation of x values, this is 570, and to the square of it, 570 whole to square, divided by 5. Here n is equals to 5. Now whole is divided by n minus 1, that is 5 minus 1 come out to be 4. Now after putting all the values, which are very simple calculations, do the calculation, get the result, and finally the standard deviation come out to be 12.25 grams. Finally the standard deviation come out to be 12.25 grams. So this is the calculation for finding out the standard deviation for a raw data or ungrouped data. Now I'm taking the example for discrete type of data or discrete distribution continuous type of data. The frequency distribution of seed yield of 50 sesame plants are given below. Find the standard deviation. So these are the seed yield in grams, 3 gram, 4 gram, 5 gram, 6 gram, and 7 gram. And 3 gram is given by 4 shisham trees or 4 plants. 4 gram is given by 6 plants. 5 gram is given by 15 plants. 6 gram is given by 15 plants. And 7 gram is given by 10 plants. If you add these frequency, it come out to be 50. So here one thing is very clear, the observation are 50, so the value of n is 50. Okay, now what we need to do according to the formula of standard deviation, if you observe the standard deviation formula for discrete continuous type of data is written as S is equals to square root summation fx square upon total number of observation minus summation of fx upon n to the whole square. So first of all, just make a table. In that, you do the square of observation and multiply with the frequency. So the fourth column, as you observe the fourth column, you find that first the observation is multiplied or square up, that is 3 into 3, that is 9, and 9 is multiplied to 4, it come out to be 36. So do fx square first, create the column, and as per the formula we require the summation. So in the last just do the total, and the total come out to be 1537. Okay, now create the second column or third column. You are seeing that fx, you just do the multiplication of frequency directly with the observation, 3 4s are 12, 4 6 are 24, and so on, and do the totaling summation according to the formula we require the summation. It come out to be 271. So put 271 divided by 50 and square up, and finally take the root, square root, and finally you get the answer as 1.1677 grams. So this is the standard deviation for a discrete continuous type of data or grouped data. I hope that you don't find any problem, because it is all in accordance to the formula. So you just create the table and create the values according to the formula, do the summations and put the values in the formula, do the calculation, take the precaution while calculating, and finally you got the answer. Now, standard deviation for continuous class distribution type of data, that is, data is provided into the class range or class distribution. Again, the frequency distribution of seed yield of 50 shisham plants are given below. Find the standard deviation. So seed yield in grams in the range of 2.5 to 3.5, 3.5 to 4.5, 4.5 to 5.5, 5.5 to 6.5, 6.5 to 7.5. And in this class range, these are the frequency or the number of plants given to you. So we need to find out the standard deviation for this continuous distribution or class distribution data. So according to the formula, we are want to put some certain values according to the formula. So I'm showing the formula to you. First, standard deviation is given as C into square root summation f frequency into d square upon n minus summation fd by n to the whole square. So according to the formula, we are required C, we are required D, and n is already given in the question, that is total 50 is the observation, 50 system plans, and frequency is already given. So we require two data, that is C and D. So just observe the table. For finding out D, we are going to put x minus a by c. X minus a by c, you are going to get the value D, and just bring out the middle value x, because in D you are putting x. So for getting the value of x, we are going to get the value of x from the class range. So what is the middle value of 2.5 to 3.5 is 3. What is the middle value of 3.5 to 4.5 is 4. What is the middle value of 4.5 to 5.5 is 5. What is the middle value between 5.5 to 6.5 is 6. So you got the x value, put x value minus a. Now, as a is the assumed mean, we are going to assume the mean, and it is come out to be 5. Okay. So x minus a minus upon c. What is c? C is equals to 1. So put the value like this and do the calculation, and finally you got the standard deviation 1.1677 for the continuous class distribution type of data. Now these are the some merits and demerits of standard deviation. Now, if I'm talking about the merits, it is rigidly defined and its value is always definite and based on all the observation, and the actual signs of deviations are used. And is based on arithmetic mean. It has all the merits of arithmetic mean. It is most important and widely used measure of dispersion. It is possible for further algebraic treatment. That means standard deviation can be used in further calculation. Why it is or where it is going to be used, I'll let you know that when we are going to start the probability. There, the standard deviation is required. So it is possible for further algebraic treatment. It is less affected by the fluctuation of sampling and hence stable. It is the basis for measuring the coefficient of correlation and sampling. Again, standard deviation is going to be used when we are going to study the correlation and regression, or finding the coefficient of correlation and regression, and in sampling. So standard deviation is very important topic. Now these are the some demerits. It is not easy to understand and it is difficult to calculate. It gives up more weight to extreme values because the values are squared up. As it is an absolute measure of variability, it cannot be used for purpose of comparison. So it is not going to give the relative measure of variability. It is giving the absolute measure of variability. So for the purpose of comparison, it cannot be used. This is the demerit. Now, come to the next topic, variance. Variance is nothing. It is the square of standard deviation. Whenever you are asked to find out the variance, you are need to calculate standard deviation for any type of data which we had seen. So variance is nothing. Variance is the square of standard deviation. Kindly make a note of it. Now coefficient of variance. Again, when you studied the variance or coefficient of variation, when we are going to find out the coefficient of variation, the standard deviation is an absolute measure of dispersion, which we had studied in the demerits. It is expressed in terms of units in which the original figures are collected and stated. The standard deviation of heights of plants cannot be compared with the standard deviation of weights of the grains, as both are expressed in different units, that is, heights in centimeter and weights in kilograms. Therefore, the standard deviation must be converted into a relative measure of dispersion for the purpose of comparison. The relative measure is known as the coefficient of variation. The coefficient of variation is obtained by dividing the standard deviation by the mean and expressed in percentage. So, whatever the coefficients we are going to calculate, first of all, they are expressed in percentage. And coefficient of variation is given as standard deviation divided by the mean. So, for calculating the coefficient of variation, first you calculate the mean, second you calculate the standard deviation, and then you do the calculation as standard deviation upon mean into 100, which give coefficient of variation. If we want to compare the variability of two or more series, we can use coefficient of variation. The series or group of data for which the coefficient of variation is greater indicate the group is more variable, less stable, less uniform, less consistent, or less homogeneous. If the coefficient of variation is less, it indicates that the group is less variable, or more stable, or more uniform, or more consistent, or more homogeneous. So this is an example. You just go through the example and calculate the coefficient of variation. It's very simple. In the example, mean is already given, standard deviation is already given. That means the observations or the data is not provided. So the calculation becomes so easy for calculating the coefficient of variation. You directly put the standard deviation divided by mean into 100. It come out to be 20% for yield, and for plant height, coefficient of variations is equals to 5 upon 55 into 100. It come out to be 9.1%. So by observing both for yield and plant height, the yield is subject to more variation than the plant height. This is the observation. Now this is the quiz time. You may just note down the questionnaires. Which measure is affected most by the presence of extreme values? Second, variance is a square of. Third is, if the CV of variety first, coefficient of variance of variety first is 30%, and variety second is 25%, then variety second is more consistent. The statement is true or false? Yes, it is true. For the set of data 5555, the standard deviation value is 0. So you just start calculating the standard deviation. When you start calculating the standard deviation for the given data, you find it come out to be 0. So we can say that the statement is true. The absolute measure of dispersion will have the original units. Yes, we had seen that in the merits, it is true. The mean deviation value for a set of data can take even negative values. No, this is false. And these are the some questionnaires for your assignments. Define dispersion. Define coefficient of variation. What are its uses? What are the difference between absolute measure and relative measure of dispersion? And the last is how to calculate the standard deviation for raw and ungrouped data. So kindly write the solution by taking appropriate examples So this is all about the deviations. Now in the next lecture, we are going to study or start with probability, basic concepts, and some definitions. So thank you all for today's lecture.